Dilations. That's what we're talking about in this first part of this unit. We're starting a new unit now. The first half of it is talking about continuing to talk about transformations, but specifically transformations that might change the size. So those are called dilations. Second half of the unit will be a little bit different. We'll be focusing on angles and different types of angle pairs. But for today, in lesson 4A, is what I've got here. It starts on page 83 in your book. This is the first part of lesson 4, and we're talking about exploring dilations and similarity. So we've got 2 learning targets today. Number 1, we'd like to understand that a dilation is a transformation that makes a scale copy of a figure, so a scale model. And number 2, we would like to explore the idea that a dilation creates an image that has the same shape as the original, but may be different size. So I would say for success criteria, if you're successful today, you should be able to locate the center of dilation on a figure that has been dilated. You should be able to create a dilated image of a figure, and you should be able to find a scale factor between a figure and its dilated image. And we're going to be working through those things throughout today and the other parts of this lesson 4 here. So start off with a question that I'd like to pose to think about. What does it mean for figures to be similar? Similar, not congruent. We've been talking about congruent, but now we want to talk about similar. So if you were to, in your book, like draw 2 congruent figures, you might draw a triangle and then the same exact triangle. Maybe it's rotated, maybe it's reflected, but maybe it's the same exact thing. And I know I did not make those perfect. Wonder if I could, I got an idea here. Watch this. Well, maybe not. Boom, copied, same image. It's congruent because it's the same. But what's different about today is when we're talking about similar, what does that mean? To you, it might mean almost the same, but not the same. And that's actually exactly what we're getting at. You might have a triangle here, but something that's similar would not be the same exact triangle. It wouldn't be congruent. But let's take a look here. It would be the same shape, but maybe a smaller version of it. Maybe a bigger version of it. It's similar because it has the same shape, but not the same size. That's kind of our focus for today. So let's look at this first example here. Number 1, in art class, Kennedy draws a scale copies of a figure A to make a rug pattern. Okay, it's a pretty cool looking rug. She uses a scale factor 3/2 to draw figure B, complete figure B by drawing the missing sides. Now, what is a scale factor? We're just jumping in using this word scale factor. So a scale factor is a number. Sorry, I switched pages here. This is actually just 2 pages away for you. It's on page 85 because we're looking at this word scale factor. A scale factor is essentially a number. Let's type it out here. A number that you multiply side lengths of one figure by to create a scale model, meaning something bigger or smaller. So if the scale factor is 2 or 2/1, so that would mean that it's 2 times the other one. If it's 1/2, it's going to be 1/2 the size of the other one. And I do want to point out one thing that we're going to use. It's called this quotient of side lengths. You want to usually take the new shape divided by the old shape, and I'll show you what that means in a second. So going back to our notes in this one, if we want to make a scale model which is 3/2, this is our new shape to our old shape, meaning the new shape, if it's 3/2, our scale factor is 3/2, new shape is 3, old shape is 2, meaning the new shape is going to be bigger. And if you take 3/2 and actually divide it out, you get 1.5. So it's going to be 1.5 times bigger. But let's just take one of these side lengths. If we have 4, we want to multiply 4 by 3 over 2, which is 1.5. And you get 6. Check it on a calculator if you want. That's why this side length here is 6 on the top. All right. So we're going to finish this out. It's going to become like these. We want it to be, this is going to be 3. We got another one that's 6. 3. 3. Another one that's 6. Because if these original ones are 2, then the bigger ones are 3. That's the scale factor, 3 to 2. 3, 6, 3, 3, and 6. Look at that. It's a bigger version of the plus sign. And I know that was quickly done, but here's the thing. Each of the corresponding parts, this left side compared to this left side, was 6 to 4. Guess what that reduces to? 3 to 2. So it's in the scale factor of 3 to 2. You can compare the new one in one of these smaller parts, like right here, to its corresponding part. The new one is 3, the old one is 2, and there's our scale factor. All right, let's look at number 2. It says Kennedy uses a scale factor of 1/2 to draw figure C. Complete figure C by drawing the missing sides. That means that each of the side lengths is 1/2 the size. So anytime the new one is 1, the old one is 2. New to old. So the old one is bigger than the new one. Meaning if we have this top side length of 4, 1/2 of 4 is 2, so it's going to have to be 2 here. Oh, sorry, I moved it. So then anytime it's 2, it's going to be 1, so it's going to make a plus sign kind of like this. All the side lengths are just half the size. Okay. Now we could look at a point, and well, I think I have one. Yeah, I think that's right. Any of the points too, like let's say from this one compared to this one, they're all going to be half the same, or half the distance away from this center, which is called our center of dilation. So big note here, put a big box around this. A transformation that makes a scale copy of a figure is called a dilation. Figures B and C are in problems 1 and 2 are dilations of figure A, because it's either making it bigger or smaller, but it's the same shape. And that means they're similar. So how did you decide how long to make the sides in figure B or figure C? Well, we kind of talked it through. So let's look at a different example here, number 3. It says a dilation may change a figure's size. In a dilation, corresponding angles are congruent and corresponding side lengths are related by that same scale factor. Complete the table to determine whether figures Q, R, and S are dilations of figure P. So figure P is in blue. So let's look at figure Q. That's the red one. We want to look, let's just say we look at one of these sides. I'll use black here. If I have the side on the right, the new one, since our original is blue, is 2. And the old one is 4. So side lengths. That would reduce to 1/2. Now if I look at, that should be the same thing on the top side. So if I go from the top one, the new one is 1, 2, 3, 4, 5, 6. The top on the blue one is 8. Now that reduces to, if you divide them both by 2, you get 3/4. Is that the same? The scale factor? No, it's not. So for Q, it says corresponding angles are congruent. Well, the angles are all right angles, so that's a yes. That's good. But the corresponding sides are not multiplied by the same scale factor. So it's not a dilation. It has to be multiplied by all the same scale factor. All right, let's look at figure R. Figure R is another smaller one. So we're looking at green here. So let's look at the side lengths. This is 2 and 4. So 2 to 4, that's good. That's 1/2. Got the same side lengths there. Let's look at the top and the bottom. So the new one, this figure R is 4. We said that the top part of figure P is 8. Now if you divide those both by 2 to simplify it, you get 1/2. So that's the same scale factor for the sides. So we can say yes here. And then for the angles, they're all right angles too, so that's a yes as well. Meaning, yes, it's a dilation. And let's do one more. Let's look at the one that's actually larger. Let's look at the P. We have the old one is 4. The new one in figure S is 6. So 6 to 4. Divide them both by 2, I get 3 to 2. So that's the same scale factor we were using before. And then tops. We got the big one is 12. The smaller one is 8. Just counting that. Those I can both divide by 4. Divide 12 by 4, I get 3. Divide 8 by 4, I get 2. And we get the same scale factor. It's bigger because the new one is bigger. But scale factor and angles are all the same. So meaning, is it a dilation? Yes, it is. Okay, so it's still the same size. Or same shape, sorry. Just a different size all around. So looking at that same one, just getting rid of the middle one, the Q, it says the point from which the figure is dilated is called the center of dilation. The center of dilation can be inside or on the outside of a figure. Use a straight edge to draw rays from the center of dilation through each of the corresponding vertices. So what that means is we're going to draw through here, here, and here. Now this is another way to look at the scale factor, like I kind of mentioned before. If we look at from like S and P, we have it's 6 diagonal units across to S and it's 4 to P. So we get the scale factor of 3/4 or 3/2 again, which is what we got before. So it's another way to find the scale factor. So for two figures, if the figures are dilations of each other, then you can draw rays from the center of dilation through each of the corresponding vertices. And if one pair of corresponding vertices does not lie on that ray, then we know it's not a dilation. So like if we go back to the example before, when we had Q in there, if I go through all of these, Q does not go through that ray, so it's not a dilation. We know the other two are though. Second thing, if at least one pair of corresponding vertices does not lie on that ray, then it's not a dilation. Pretty neat way to check too. So finally, based on this center of dilation, can you draw rays through each pair of corresponding for P or R and Q? No, you cannot. They are not the same. So one of them is not a dilation. And that's kind of our intro to dilations here. It's getting bigger, but it's getting bigger by the same amount each time for the side lengths. So I'd just like you to reflect now on what we just talked about. I know it was quick, but does a dilation change a figure's shape? How is a dilation different than a translation, rotation, and reflection? So think about those questions and answer that right here. And then I just want to just touch on the goals for today. We wanted to get through two things really. Understanding that dilation makes a scale copy. So we talked about scale models, but also scale factors. And then number 2, explore the idea that dilation creates an image that has the same shape as the original, but a different size. So looking at those success criteria, do you feel like you're successful or is there something that you could work on? That's it for lesson 4A. We'll see you next time.